All right, today we're going to talk about lesson 8.2, which is on rates. I highly recommend making sure that you have a calculator ready to go if you're following along, whether you're taking the notes or not, or doing the examples with me. But you're going to definitely want a calculator for this one when you're doing the IXLs as well. So let's take a look at my notes. So our learning target for today is I can calculate a unit rate using division. So that's why you're going to want your calculator out because you're going to be doing a lot of dividing. Our lesson on today is about rates, but specifically what we're going to talk about is unit rates. Those are going to be way more useful for us than just what a rate is. So if you take a look at our definition of rate, our definition of rate is very similar to what our definition of a ratio was yesterday. A rate is a comparison of two quantities that have different units. So the only thing that it is the different units. That's the part that's the difference between a ratio and a rate. So a rate is a special type of ratio. So we use rates all the time. When we're driving, miles per hour, that's a rate. Let's see, miles per gallon, that's a rate. When you're going to the grocery store and you're buying something, so there's a price per pound. Those are all rates. So we use rates all the time. So my example that I used for you was 60 miles per 30 hours. So we usually use the word per when we're talking about rates. Now you will notice if you look at my 60 miles per 30 hours that can be simplified. If I was to do 60 divided by 3, I'm going to get 20 miles per 1 hour, and that is a specific kind of rate that is called a unit rate, and that's what we're going to be using today. So if I do 60 divided by 3, I get 20 miles per 1 hour, which instead of saying 20 miles per 1 hour, I would just say 20 miles per hour. You can write the word per, you can put a slash on there like I did. It's totally up to you, okay? So the only difference between a rate and a unit rate is when you have a unit rate, you're comparing something to the number 1. So in my example, I have 60 miles per 3 hours. So I'm comparing the number 60 to the number 3, so that's a rate. But when I divide 60 divided by 3, I end up with 20 miles per 1 hour. So that is a unit rate because my denominator is 1. I'm now comparing my 20 miles to 1 hour. So unit rates make things a lot easier for us, so that's what we're going to be doing today. So let's take a look at our first couple examples. It says find each unit rate, round to the nearest hundredth if necessary. And I've got my calculator out ready to go. So if I need to use that, it might take a little longer in between my talking. So let's take a look at number 1. In number 1, I have 145 students in 5 classes. So I have 145 students. I'm just going to write a ratio here, and it's going to be a rate. So I have 145 students to 5 classes. So I want to change this to a unit rate. I want to know how many kids are in one class. So all I do is I divide, and my division problem is going to be right here. All it is 145 divided by 5. When I do 145 divided by 5, I get 29. Now labels are really important. The two things I'm comparing are students in class. So there's 29 students per class. You can write the word per, or you can do a slash. It's totally up to you. All right, let's take a look at our next one. I have 256 miles on 8 gallons of gas. So the two things I'm comparing is miles, so I have 256 of those, and gallons, of which I have 8 of. But I don't want to know miles per gallon or miles in 8 gallons. I want to know how many miles in 1 gallon. So all I need to do is divide, and my division problem is right there. It's always going to be what you wrote down as your numbers. So 256 divided by 8, I get 32. So that means there's 32 miles per gallon. And again, you can use a slash, or you can write the word or per. It's totally up to you. All right? So that's pretty much what we're doing today. Now let's take a look at a couple other examples. So I've got a graph here. Number 3 says, Mr. Lombard flew his hot air balloon to school and made a graph of its height after a certain number of seconds. Why is he flying a hot air balloon? Well, why not, I guess. We want to find the unit rate in feet per second. So if I take a look at my graph, we're going to notice I'm comparing feet and I'm comparing seconds. So those are going to be my 2 units. On my graph, I have an ordered pair right there of 6:30. So that means that ordered pair is telling us at 6 seconds, he is 30 feet in the air. Okay? So I'm comparing feet and seconds. So my unit rate says feet per second. So I want the feet first, and that was 30. And it was seconds is second, so it was 6 seconds. Now I want my unit rate, so I'm going to divide 30 divided by 6. That means that he went 5 feet per second. And we're already done with our first part of our problem. All right, number 2, or letter B. If the hot air balloon continues to rise at the same rate, what will its height be after 20 seconds? Okay. So my unit rate is 5 feet in 1 second. But I don't want it to be 1 second anymore. My problem is telling us that we want 20 seconds. Okay. So to go from 1 to 20, I multiply by 20. So that means I need to multiply 5 by 20. We get 100. So Mr. Lombard is going to go 100 feet in 20 seconds. Letter C. If the hot air balloon was 100 feet in the air, for what number of seconds was it in the air? Well, if we take a look at our last example, it pretty much tells us right here for us. So I have 100 feet in 20 seconds. Okay. So it's going to be 20 seconds. Our answer is going to be 20 seconds. Another way to look at it would be if I rewrite my unit rate of 5 feet in 1 second. The question is telling us that we don't want it to be 5 feet anymore. We want it to be 100 feet. So it's the same thing that we just did. To go from 5 to 100, I multiply by 20. So I would multiply the 1 by 20, and I would get 20 seconds. So either way you do that problem is fine. So it's a lot of critical thinking to solve some of these problems. All right, unit prices. So what a unit price is the same thing as a unit rate. So instead of figuring out how much 5 pounds is, we want to know how much 1 pound is. Okay. So number 1 says $8.99 for 5 pounds of apples. And money's always going to go on the top. So I have $8.99 for 5 pounds. But I want to know how much it costs for 1 pound. So all I'm going to do is divide. I'm dividing right there. $8.99 divided by 5. And I get kind of a weird answer. I get $1 and it says 798. But we're talking about money. You can't have that one right there. We can't have that 8. That 8 means we round up. So if I round up, the 9 actually turns into a 10. So this gets kind of messy. This is going to be 80. So I have $1.80 per pound for my apples. All right. Number 2, I have $2.35 for 12 eggs. I don't want to know how much it is for 12 eggs. I want to know how much actually it is for 1 egg. So I'm going to divide my $2.35 divided by 12. And again, I get a really crazy answer. I'll write it down for you so you can see. It ends up being 0.195. I'm going to stop right there. I look at the 5. The 5 means I need to round up. So that 19 cents actually turns to 20. And that means that I pay 20 cents per egg. Okay? All right, when we are doing unit prices, a lot of times when we're doing unit prices, what we're doing there is we want to do that so that we can compare and we can find something find our best deal. So our example for this is about chicken nuggets or McNuggets, even better. So number 3, McDonald's sells 3 different sizes of chicken McNuggets. The cost of each size is displayed in the table. Find each unit price in dollars per nugget. So my 10-piece, if I look at my 10-piece, it costs $4.49 for 10 pieces of chicken nuggets. So I want my $4.49 on the top, and I've got 10 pieces on the bottom. So I'm going to divide, and when I divide $4.49 divided by 10, I end up with, if we just move the decimal point over, 0.449. Now, I'm going to keep it like that because, 1, I don't need to round. My question doesn't tell me that I have to. But also, I'm comparing something, so I want as many digits on there as I can to be able to compare just in case things get really, really close. So if I buy the 10-piece chicken nugget, that means that I'm roughly paying about 45 cents per each nugget. Now, if I buy the 20-piece chicken nugget, that's $5. So it's $5 for a 20-piece chicken nugget. So I need to do $5 divided by 20. And if I do that, I end up with exactly 25. Oops, I screwed that up here. I end up with exactly 25 cents per nugget. So already if I compare those two deals, I see that my 20-piece chicken nugget is significantly cheaper. Okay. All right, let's take a look at the 40-piece. So the 40-piece is $8.99. So for the 40-piece, I get $8.99. This one's 40 pieces. So I'm going to do $8.99 divided by 40. And I get roughly, it's about 22 cents. I'm going to round it to that per nugget. Okay. So there's my answers. So if I buy the 10-piece nugget, I'm spending about 45 cents per nugget. If I buy the 20-piece, I'm spending 25 cents per nugget. If I buy the 40-piece, I'm buying about 23 cents per nugget. Letter B says, what size is the best deal? So I'm comparing which one is cheapest. So there's my cheapest one right there. Okay, so the 40-piece nugget is the cheapest. And that is because the unit price per nugget is the lowest. I wonder how many of you could house 40 nuggets. I don't know if I could. That's a lot. All right, there we go. That completes our lesson on rates. You do have an IXL, 2 IXLs that you need to do. One's on unit rates, one's on unit prices. Message me on Schoology if you need any help. Talk to you later, guys. Peace.